Okay, hello everyone. This is Xiaohui Qi from Northumbria University of UK. Firstly, thanks for Professor Chao for your introduction, and also thanks for Professor Zhang for inviting me to do this presentation. Today, the topic is a comparative study of several spatial prediction methods of the elevation of soil-rock interface, which is also called rockhead. And this work was done when I worked in Nanyang Technological University in Singapore. And this work has been published in Engineering Geology in 2020. If you're interested in these details, you can look have a look at the paper. Here's the outlines of the presentation. First, as the background, followed by the methods, which introduce three methods I'm going to compare, including the spline regressions, spline interpolations, and the condition random forest methods. And this comparison will be illustrated using some borehole data from Singapore. And last is the conclusions. The background in our civil engineering is not uncommon to encounter soil rock interface or rockhead in underground constructions. For example, in the tunneling, in many tunneling projects, the soil rock interface can affect the excavation and the support of the tunneling. And for the slopes, the rockhead can affect the failure modes or the failure scale of the landslides, especially for shallow landslides. So it's very important to predict the location of the rockhead in areas between boreholes. To address these issues, the NTU, the Nanyang Technological University, has a research project to establish a 3D geologic model for the underground exploration of the Singapore. We have used more than around 60,000 borehole data from the past project. But the major problems is for the most boreholes is too shallow to reveal some important geological interface information, such as the rockhead. So it's very challenging because of limited data, it's very challenging to predict the rockhead elevation. Another challenge is that we also want to know, in addition the prediction, we also want to know the prediction error. We also, in other words, we want to know the confidence interval for any predictions. So in the literature, there's a different types of spatial prediction methods. It can be generally be divided into two categories, including the determinist methods, such as the inverse distance weighted methods, spline interpolation methods, and so on. And for probabilistic methods, it may include the Kriging methods, conditional random methods, and spline regression methods. And the different methods may have different advantages and disadvantages. For example, for the inverse distance weighted methods, the major disadvantage is very sensitive to clustering and outliers. So it's necessary to compare these different methods so that we can select the most suitable one. Here we choose three widely used methods, including the spline interpolation methods, spline regression methods, and also conditional random forest methods. These three methods are chosen because because we can have some insights from these comparisons. Here is the second part of the methods introduction. As you may know, the splines are piecewise polynomial functions. it can either be high order or low order, such as linear functions. So the spline regression method is to find out a spline representing the midpoint of the raw height elevation, and also to evaluate the deviation of the data points from the midpoint. And for the spline interpolation, is to seek a spline run across all the data points. So for the both methods, the response variable, which is a spline, is expressed weighted average of spline basis function. This spline basis function has known function forms. So the only unknowns are these unknown regression coefficients, which is denoted as beta herein. For example, here we have some SBT data. We do a curve fitting using different numbers of basic functions. Here we use a cubic basic function. As you can see, when there's only 3 basic functions, the fitted curve is the left plot is the left most figure. And as you may notice, this fitted curve consists of different pieces of polynomial functions, and these connection points of these different pieces we call the nuts here. For example, the dashed line represents the location of the nuts, and in the center figure, the fitting outcome is using 6 basic function, while on the right hand side is the fitted curve using 12. And for the right hand side one is the fit curve running across all the data points. So this is the spline interpolation. So the natural questions is for the spline regression, how to select the number of the basic functions and also the location of nuts. Here we use model selection methods, the Bayesian information criteria, to select the numbers of the basic functions. So this criteria is considered not only the fitting error, but also has a penalty against the complexity of the curves. And also for the locations of nuts, we use stochastic statue methods, which is introduced in this reference. Another method we like to compare is the conditional random field methods. And essentially, this method is a Bayesian method. It has some prior statistics. Firstly, we have some prior statistics of the raw height elevation. This prior statistics is the main trend, as well as the standard deviations. It comes from some prior knowledge from engineer. It can also be estimated from the known data. And secondly, we need to use some spatial autocorrelation information to update the statistics of the raw height elevations. This spatial autocorrelated information is denoted by this scale of fluctuations, which is similar, as you can see from the right hand side. The different numbers of the scale fluctuation is lead to different autocorrelation functions, which is very similar to the semi-parallelogram figures of the creation methods. So once this information is available, we can update the statistics of the raw height elevation. So for example, when we know that distribution is a normal distribution, so the updated statistics will be denoted by the formula on the right hand side. So the posterior means is equal to the prior means plus the weighted average of the residual value of the observations. So if you compare with the formula of the splines, you can see it's very similar. Both involves a weighted average. The only difference is for the conditional random field methods, the weight it determines from the autocorrelation information. So here we use an example from Singapore. We use some borehole data located in the central south part of the Singapore. As you can see from here, these solid lines. So these boreholes has revealed the raw head of the Bukit granite, which is an ingenious rock formation in Singapore. It overlies 1/3 of the Singapore Islands, which is also the base rock of the whole Singapore. And also, it's worth noting that here there's some faults. There's some faults which lead to very variable raw head elevation. And because of the humid weather condition and also the past tectonic events, the Bukit raw head has very intensive weathering. So we use some borehole data located along a road in this area. There's around 110 boreholes, and as you can see from the bottom figures, the raw head is denoted by these triangle symbols. But you can also see that some boreholes are too shallow to reveal the actual raw head. For example, the triangulars denoted by this black with these black colors. So that means even the boreholes when we reach the bottom of the boreholes, we haven't reached the raw head. So we need a data processing process to select the data. And also it's worth noting that the raw head is defined as an interface of rock mass with a varying grade 1 to 3, and with that it was varying grade of 4 to 6. And the varying grade is mainly determined by the engineering experience. It can be determined from the strength, the sounds, and color. So as you can imagine, there's a lot of subjectivity involved. So this also contributes the uncertainty in the raw head elevation. So the first step is the data processing. First, because all these boreholes are located along this road, so it's a typical one-dimensional analysis. So first thing we need to project all the boreholes into a projected lines. So the natural question is how to select the boreholes, how far away it should be the boreholes from the boreholes to the projection lines. So we do a very simple and preliminary statistical analysis. We just plot the difference in the raw head elevation for any pair of boreholes. And as you can see, when the separation distance of boreholes exceeding 60 meters, the difference of the raw head elevation can increase significantly. So that means that when the boreholes are more than 60 meters away from the project lines, the raw head elevation of boreholes may be quite different from the project lines. So we just select the boreholes within 60 meters of the project lines. And also, as I mentioned previously, some boreholes are too shallow to reveal the raw head. For example, the boreholes represented by this black triangular symbol. In this case, we just select those boreholes, whether the boreholes are deep or shallow than the neighboring boreholes. For example, these three boreholes, the three boreholes in the rectangular, these three boreholes has revealed at the borehole bottom haven't reached the raw head level. So, but we still assume that the raw head elevation is located at the borehole bottom, because if these three boreholes are not used, if its three boreholes are ignored, the predicted curve will lead to a significant overestimation of the rock head elevation, such as these pink lines. This pink lines is the result without consider these three boreholes. So we still use these three boreholes. We use three boreholes in the spatial interpolations. And then we do a comparison of the different methods using a cross-validation procedure. We use 50% of data as training and the remaining 50% data as testing. And the top figures illustrate the outcome of the spline regression methods. As you can see, at the geological complex area, such as here in the center and the left-hand side, the geological is very complex. So the methods can automatically place more nuts at these areas. So it's the spatial trends can be captured. And another feature is it can provide the complete interval of the rock head elevation. While for the spline interpolation methods, all the predicted curves running across all the data points, and also there may be some undesirable oscillations, such as here, as you can see here. And furthermore, for these spline regression methods, because as I has mentioned, it consists of these different pieces of polynomial normal functions. So we can use these different pieces to capture the non-stationary in the uncertainty. For example, as you can see in the central part, there's more borehole data, while on the right-hand side, there's less borehole data. So correspondingly, so the uncertainty, which denoted by the standard prediction, standard deviation of the complete interval is wider than the central parts. And this is another advantage of the spline regression methods. And also for the spline regression, another features because of the cubic polynomial function, we can easily calculate the first derivative. So from this information, we can guide site investigation. For example, here, the first derivative is very large. It denotes a very sharp increase in the rock head elevation. So we can place more boreholes when we do site investigations. So at last, there's some results for the conditional random field methods, as you can see in the top figure. As you can see, from the solid lines denotes the predictions. As you can see, there's many spikes in the data points, and the predicted curve cannot be larger or lower than these data points. So that means that the extreme values only occurs on these data points. So this is not realistic. And another observation is that, for example, even some areas is geologically complex, but the confidence interval, as denoted by these dashed lines, is not very not quite different from our other areas. So it cannot reflect the geological complexity. So if we use two sets of data and do multiple predictions, we can see that similar observations can be observed. And here, at last, its conclusions. First, the spline interpolations has a lower prediction accuracy and also has some undesirable oscillations. And also, for the conditional random field methods, it can produce unrealistic profiles. And at last, for the spline regression methods, can reasonably quantify the prediction uncertainty and also differentiate the zones with different uncertainties. So at last, there's some reference, and thank you for attention.